Yo, Algebra 1. So we had a few multiple choice questions on the back of today's work, so I thought I'd make a quick video now that I'm home from parent night to kind of give you an idea of what you're looking at. Which explicit formula is represented by the graph? So on the bottom independent axis we have the term number, which I have laid out on the x side or the left side of our table. On the right side represents the term value, so the first term looks like it's roughly 2, and then the second number is roughly, the first number is 1, the second number is 2, the third number looks like it's roughly 4, and then it's 8, and then it's 16. So definitely geometric, exponential. That's why we see the exponent as a variable. This is 1 to the n minus 1 power, or negative 1 to the n minus 1 power. And so when you kind of need to think about this right side, the output, what seems to be happening there, how am I getting to the next number using multiplication? And so we're going to look at our notes here and think, okay, it was a sub 1 times the r value, and whatever that value is, it is raised to the n minus 1. So there's some really complicated looking just text math. But basically the first number is 1, so we have a 1 out front. Sometimes that number can be invisible. It just depends on how it's written. It seems to be multiplying by a coefficient that's really simple that gets you down the line. And so we'll definitely check that one tomorrow, but always make sure the input-output works throughout the problem. Okay. Number 11, what is the next term in this sequence? 1.35, 4.49, 7, 10, 13. So when I look at that, I'm thinking, okay, 1 to 4, 4 to 7, 7 to 10, these are all roughly 3, and if you subtract them to find the common difference, you notice that it's exactly 3.14. Kind of made me think about pi. That's not pi, that's an estimation of pi. Pi is an irrational number that goes forever and ever and ever, but that's roughly what it's equal to. So just continue that term, continue that sequence for the next term, and I think you got that one pretty easily. The one on the right here, which represents the recursive formula. Recursive means you're basically saying, okay, if I want look at D with me here, it says, if you want the third term, we'll take the second term and do something to it. Or maybe if it's A or B, take the second term. If you want the second term, take the first number and do something to it so you can get the next number. So I kind of made a table here so you can kind of study, like the n is replaced with 1 or 2 or 3. And if you can calculate what that should equal, kind of gives you an idea of what the sequence would be. And so if you can imagine what the sequence is, and you can kind of start understanding if it's multiplying by 2 or negative 2 or negative 3 or positive 3. And so definitely explore the little table that I've got here and calculate what each of these would be as you're replacing n with different integers, and then you'll clearly see the final answer. 13, Brittany is a scientist. She's recording the number of cells in a dish, and each hour it's dividing into 4 different cells. And you want to be careful about that word division, the divides. It's not really division. If you notice 1, 4, 16, 24, it's more of a form of multiplication. But what we think about is if you divide into 2, for example, if I took this piece of paper and I divided it into 2, it would go from 1 into 2, and it's a concept of multiplication that's more application. That word doesn't strictly mean the idea of division in the way that you would think in a math class. So be careful about that. But basically, I wrote the generic form of what we need here. And so the first number, think about the first number in the sequence. What number does it seem that I'm multiplying by to get to the next number? And then we just kind of pick the right answer here. Last one, Raymond's filling his kitchen sink, and they tell you how much after 1 minute he has in terms of gallons of water in the sink. Same thing with 2 minutes, same thing with 3 minutes. So let me move that out of the way so we can kind of see. And so here's a quick table of the minutes to gallons ideas. And so what we're trying to do is figure out how many gallons of water will be in it after 5 minutes. So you could just go ahead and recursively kind of add that value on. That seems to be arithmetic, getting you to the next term. But in terms of preparedness for the quiz, I thought I'd show you a more explicit way to start this. So if I wanted to create an explicit formula where I can basically calculate any number I want, maybe it's 5 minutes, maybe it's 20 minutes, maybe it's 100 minutes, I just want to plug that minutes into the equation and it pops out the number of gallons real quick. So basically I start with the first number, 2.75, and then 2.75 is actually the common difference. If you were to subtract any of these numbers, you're going to see that it's adding 2.75. So I need to distribute that and combine these. This is actually going to just cancel out real easy. 2.75 minus 2.75, and so this is the only thing that survives. 2.75 in. So basically I can just plug in whatever term I want, and I'm multiplying it by 2.75, and that would just tell me my final answer. So if we want the fifth number, plugging in 5, you should get 13.75, which it looks like is C. Hope this video was helpful. We're going to have a quiz tomorrow, so take a look over your notes, all your vocab, and definitely want to make sure you memorize formulas like the ones that I've done in the video here. Definitely want to know how to build an explicit formula for arithmetic or geometric. Same thing for recursive. So good luck, study your heart out, see you tomorrow. Peace.